For today's lesson, our focus standard comes from Grade 8, Expressions and Equations, Standard C, Analyze and Solve Linear Equations. Our topic comes from Simplifying and Solving Equations, where we are going to set expressions equal and solve for x. So we've done a lot on analyzing and simplifying expressions leading up to this work that we're now going to do to solve linear equations. So our essential question is, how do the steps to compare two expressions relate to setting expressions equal to solve for x? So how does the work we've been doing where we compare, how does that similar or different from the steps that it's going to take to solve for x? So let's jump right in and discuss that. Please make sure that your header is set up, including today's date. And so there are some steps to simplify and solve, and there's some similarities. The first two steps are going to be exactly the same as what we've been doing. So go ahead and mentally think or jot down in your notes, what are those first two steps? So the first step you should have thought of to jot down was to simplify, and we know that that comes from flipping tiles, which we now refer to as the distributive property. And that then we look to combine like terms, which includes removing zero pairs or things that cancel out. And we of course record our work all the way through. The second step that should have come to mind is balancing, and so that's where we talk mostly about what we do to one side we also have to do to the other. In dealing on maths, we've removed identical tiles. We're starting to change that a little bit and realize, hey, I can also add things to the mat that's going to zero things out, as long as I keep it balanced and I add things to both sides. There is one more step that we're going to add in, and that's right here on step B under balance, which would be to get all the x terms or all the variable terms to one side of the equation and get all the constant, all those number terms to the other side. So if we want to separate the different types of terms on either side, all doing balancing moves. So what I do to one side, I also have to do to the other. And then that sets us up to be able to do this third step. So in comparing, we would just look at what's left and compare them. When we're solving for x, though, we're trying to find out what just one x is. So that third step is to isolate the x, to determine the value of one x. The way that we do that mathematically is to divide both sides by the coefficient. Our fourth and final step then, so this should give us a solution, but our fourth step is to make sure that we're right, that the work we did in steps 1 through 3 are correct. And so the way we do that is we test our solution. We plug the value for x into the original problem, so what we got here when we isolated, we plug that value into the original problem and solve. That would take order of operations. And we will know we're right if both sides are equal. So we're going to set this up for our first problem to do it the same way as we did before. Set up a table with 5 columns. We're going to do the work on an expression mat, but we're also going to show this work with the equation and give an explanation. So this will look more like traditional algebra here in the middle, always relating to what we've been doing to build up our skill level and our understanding of this concept. So here's your problem. Copy this expression mat down and go ahead and see if you can write the equation. What is the expression here on the left and what is that expression on the right? And the explanation for this should just be that this is the original equation. So the equation that I would be looking for would look something like this. So on the left hand side we have an x plus 1 minus the quantity, so what we have in this lower region, 1 minus 2x. And all of that is going to be equal to what we see on the right hand side, which is 3 plus an x minus 1 minus the quantity, so I'm subtracting what is in this lower region, and x minus 4. So now we're ready to start putting these moves into place. So our first move, if we're looking on the expression mat, right, should be to flip tiles up. But then what is that going to look like, right? So here's our explanation. We know this. We're going to simplify by flipping, and we're going to use the distributive property. What I would like you to do now is show that work on both the mat and your expression mats, and then compare your work with mine. So we know on the mats that we have to show our work by this, that we're going to flip those tiles up. And what we end up with is something that looks like this, keeping everything that we had. And then these negatives, x's become positives. This positive tile becomes negative. Over here on the right-hand side, this positive x flips up to become negative. These four negatives flip up to be positives. So I've also drawn in my work here for what that would look like on the traditional algebra way of showing our work of doing this distributive property. We now know that that negative sign is hiding a negative 1. So it's a negative 1 times 1 and a negative 1 times a negative 2x, which on our expression is we're keeping this x plus 1. And then negative 1 times 1 gives us negative 1. And negative 1 times a negative 2x gives us a positive 2x. On the right-hand side, we're going to keep the 3 plus x minus 1. So on the right-hand side, we're going to keep the 3 plus x minus 1. And then we're going to distribute through. We know it's a sneaky 1 here. We're going to multiply what's in the parentheses. So here's that 3 plus x minus 1 that we're keeping. And then negative 1 times an x gives us a negative x. And negative 1 times a negative 4 gives us a positive 4. So that was just our first move. On the algebra mats, we flip the tiles. On our algebraic equation here, we use the distributive property, showing our work with these arrows up above, and recording what we got by distributing that negative 1 through on both sides. So what's our next step? Once we need to continue to simplify it, and we need to combine those like terms. I'm going to do 2 moves here. I'm also going to do the balancing move. So let's take a look at it though one at a time. So combining like terms, what is that going to look like here with these parts of our equation? And what is that going to look like on our mat? So here you can see on our mat, to start to combine like terms and remove 0 pairs, I've circled things on the left and on the right that make 0 pairs. And that just leaves us with these 3 x's on the left and these 6 unit tiles on the right. As far as this combining like terms on our algebra equation here, I've highlighted things that were the same. Looks like I missed one number. Should be highlighted green as well. So on the left, remember we only combine things and keeping it divided here with this equal sign. This x plus 2x give me those 3 x's. And then this positive 1 and negative 1 actually cancel out. So if you had those highlighted or you want to cross them off to say, I know negative 1 minus 1 is going to make 0, that would be okay. And it leaves us with just these 3 x's. On the right-hand side, our positive x and our negative x actually cancel out. And so x's go away on the right-hand side. And if I have 3 plus 4, I have 7. Minus 1 is 6. And so I end up with those 6. So we end up with 3x equals 6. That's what we see here on our expression mat. The balancing, I wrote that in here. That's something that we would need to look for. But it has naturally happened by things canceling out. So it's important to check and make sure that this happened. We have only x terms here on this left-hand side. There's none over here. And there's only a constant term on this right-hand side. There's no constant term of just a number with no variable on the left-hand side. So that's part of balancing. If that was not the case, we'd have to do some more work, balancing moves to each side until we could get all the x's to one side and all the constants to the other. So now we're ready for that third and final new step with solving equations, which is to isolate the x. So we want to isolate the x and decide what the value of just one x is. So I'm going to do that first. If we look, we can start to just see, and I think I have just we're going to bring down the same thing, but we want to say, well, look, I can just take a look here and divide this. So if I divide it into equal groups of 3, I'm going to have an x and on each group, and I'm going to have 2 units on the other. So you can see how I'm circling that here. making sure that our groups are even, and they are. So each x is equal to 2. So x must be equal to 2. The way we show that with our algebraic equation is that we divide each side by the coefficient. So I again just copied this part, 3x equals 6, but now I'm showing with the fraction bar that I'm dividing this by 3 as well as this by 3. So kind of like the balancing. Whatever I do to one side, I have to do to the other. So we do that where we divide by 3 because that is our coefficient on the x term. And 3x divided by 3, these 3's cancel out, leaving me with just an x. And 6 divided by 3 is 2. So we see that same answer, x is equal to 2. So we know that our final answer is x equals 2, but we have to do the work to prove it. So now that I know that x is equal to 2, we have to do that fourth and final step to check that all our work is correct, which is to test the solution. And what we're doing is we want to plug in 2 for everywhere we see x and make sure that both sides are equal. So I'm going to go through this part kind of quick and just show you my work. So here's the original equation, copied down from that very first row in our table. And then everywhere that I saw an x, I'm using parentheses to plug in a 2. So there was a 2x here, and so now where that x was, I added an extra parentheses for that 2. There's an x here, I added parentheses for a 2 in here. And now I'm just using order of operations, so working within the parentheses, 2 times 2 is 4, and copied everything else down. Over here, 2 minus 4 was a negative 2. That's inside my parentheses there. On the left, I still need to simplify the parentheses, so I copied down everything else. But 1 minus 4 is negative 3. On the right-hand side, that sneaky 1 is right here again. And so this is a multiplication. Negative 1 times negative 2 gives me a positive 2. Still copying down everything else. Over here, I still have that sneaky 1. So negative 1 times a negative 3 gives me a positive 3, copying everything else down until I get down to the adding and subtracting. So 3 plus 2 minus 1 plus 2 gives me 6. 2 plus 1 plus 3 gives me 6. Both sides equal out to be 6. So this value, x equals 2, must be my final answer. So I know that I did the steps 1 through 3 is correct, and I'm ready to report that the final answer from our original equation was that x equals 2. And that's going to conclude our video here. Please make sure your notes are complete, and we'll do more work with this in class.